you might be having different experience in construction related projects. So I'm very thankful to Dr. Amit, for the course coordinator, for allowing me to speak on like a topic which is research oriented topic. Although Dr. Amit and team from NITTR Chandigarh, they remain involved mostly in the projects which are like application of theory projects. So those kind of projects is when he requested me regarding this construction advanced construction technologies program, it was like he reminded me of my master's time when I was working on this construction. My PGs from IIT Kharagpur, where I did my PG in infrastructure design and management. So their construction technologies used to be the application of these kind of technologies used to be very high. And I also remain involved in one of the project where the theory was implemented directly into the construction technology, which was then sold to one company. And at that point of time, it was like it yield to one PhD also, Dr. Uma Shankar. So that I'll appreciate him also, who helped me in continuously remaining involved with him. So whenever we are engaged in any sort of construction activity, a large number of resources which are in the form of man, machine, materials, money, let's say time, all these resources require planning. And all projects, whether it's a small project or a large project, we remain involved like different set of mindset. We keep on asking questions to ourselves regarding how to use it, where to use, what kind of resources, what are the resources those are available, why should a particular type of resource only to be used, and how can we optimally utilize these resources. So decision making in these different forms remain involved, whether it is in our front of mind or back of mind, so that those decision making capabilities remain involved there. So at the time whenever we are involved in such kind of projects, so those decision making tools, whether it is by human nature or learning in the natural form, or by the scientific knowledge that we are having, so that applications we make. So some of the tools that you might be using the CPM, PERT, MS Project or Primavera, these kind of tools you might be using for like your construction management or planning of the activities that are related to construction. So, but with the increase in size of these projects, we require specialized kind of techniques, or let's say planning tools to optimize the resources. The basic tools like Gantt chart, CPM, PERT all remain in background, and the specialized tools of the network based or simulation based tool techniques takes the center stage. So with the help of these tools, we remain like either the, let's say, scientific tool or the natural learning that we are having with our experience. So those two things keep on going regular from one time to another time. So those things remain there. So those kind of things remain involved into our project making. So at the same time, when two things remain involved, we remain involved in making, when the sort of things remain, or let's say resources that we are involved with, they increase with the size. So the specialized tools come in picture. So these tools, when we start making a decision by using any of these tools or any of the resources that we are having in our hands, so those tools, when we make a decision, we remain unaware about what are the future consequences. These things, these tools, these resources, they try to squeeze us, and they remain continuously developing a pressure on us. So those kind of pressure we try to push off without even thinking about the future consequences, what they are. So why we are thinking about the system dynamics? See, all these techniques that we are using, be it Primavera, or let's say this project management by using CPM or PERT, any of the technique. So they all are linear process response system, where we are having some input in the form of resources. We try to control or process these input, the raw materials, with the help of the management skills that we are having, and we develop an output. So that's the linear system that we are following in our system. Along with that, in some of the firms which are like world class firm, let's say call it JLL, I have worked with. And so at that point of time, we also record in most of the firms nowadays, we record the output also, that we record this process, and we put this process in channel. So by putting this process in channel, we record this and we provide a feedback system to the new project. However, within the same project, it remains absent. So along with it, so this is the thing that happens to us. We make a decision, we forget whether the decision is going to strike back to us. So the system learning approach allow in the construction management project that the same thing is going to hit back to us. Let's say a company takes the bank guarantee that in some construction project, if some fault is there, and that bank guarantee will be retained for, let's say, next 5 years. So for that purpose, we prefer to go with one decision is made for a construction if we'll be using lower quality of the materials. So that lower quality of material can lead to the same loss of 15% or 5%, whatever the amount we fix for bank guarantee for 5 years. So that can lapse because of the short decision making or the low grade material usage. Same can happen with the low manpower skilled or unskilled labor that we use. So those decisions will hit us back. So this kind of situation can be tackled with the help of system when we are thinking in terms of systems approach. So in at the other end, when the project size increases, there remains large number of people involved from different disciplines, be it the HVAC guy, be it the construction engineer, let's say a civil engineer or mechanical engineer, or the architect guy, or the electrical engineer, and the unskilled labor or the skilled labor that we are using. So they all visualize that construction project from their own end and from their own viewpoint, without looking at what others feel or what others think, or the others perspective. So it is the responsibility of the project manager to have all the skill set, and all the skill set, the project manager should be able to deliver what was exactly perceived by the architect or the client. So this is where we lack. So to unify such kind of things, we require high-ended project simulation softwares or techniques that can help us in delivering the exact projects that we should, or as a project manager we should. So why system can be justified? Because it allow us to think in terms of holistic approach, gives us a holistic approach, and that is actually based on the feedback system rather than the linear processes that we are following in our construction techniques. So a system is basically a set of things working together as a part of a mechanism or interconnecting networks or a complex whole. A system can become, it depends from one person to another person. A system, the boundary of the system can be defined with the help of different things to the level of knowledge that we require. So system boundary we can decide. The set of principle or procedure according to which something is done, an organized scheme or method. A cycle can become a system where the different tools are being organized. Same is the case with the car. It engaged with different electronic system, mechanical system, let's say architectural design component, or same as our human body is another system. So buildings are also part of system. So the entire thing means the from the part to whole they remain connected, and all these parts are connected, and the holistic approach only allows us to function the entire building in anonymity. So these kind of things will allow only the entire functioning of the total building. So this is justified. The similar kind of thing we can say that the basic things that I'm putting forward before going to the detailed system dynamics approach in construction management. So when we open a tap, our mental status say that the glass is going to be filled, so we should close the faucet. So the desired level, after achieving the desired level, the perceived gap or is filled, and we start closing the tap. So such kind of things should be there in construction management things also. So similarly, like we cannot hire n number of people for a particular project, so and that cannot be retained for full time in the entire duration of the project. So there are some properties of the system. See, when we are looking at without systems perspective, we are looking at things in disconnection. So interconnections or interconnectivity is being ignored. We look at the things in linear manner. The circulation or the vicious cycle of the materials or the decisions are not being looked upon. We looked in the silos. Emergence is being ignored. We looked in terms of parts, the holistic thing is ignored. So the analysis, synthesis, all these things remain present in the systems approach. When you start thinking in terms of relationship, synthesis, and cyclic manner, emergence, interconnectiveness, wholeness, then you'll start thinking in terms of system. So we what we can do with the system thing, we can map behavior over time graph. Time is one component where this system dynamic technique is applied. So at the same, it is like in a similar manner, whenever the time quotient is there, we can calculate or map different behavior. We can use different iceberg model, causal loop diagrams, connected circles. All these things can be used for mapping the systems approach. We can look at the holes, we can look at in a linear or non-linear manner, we can synthesis, relationship networks, processes. All these things can be mapped by using systems thinking. So while starting with systems approach, we need to specify the exact problem, the issue, where the system dynamic thinking, system as a cause, or identification of cause and loop or cause and effect is required. Then the forest thinking is required. So then we construct some hypotheses which are part of operational thinking, which preferably should be closed loop. Although the open loop things can be targeted, but for calculating the quantifying those things, we require closed loop part, and that's where the quantitative thinking is put forward. We can have a particular mindset. That mindset can be mapped into the mental model, can be mapped into system dynamics to produce quantitative thinking. So then we test the hypothesis by using some cases, and that's a scientific approach that we all follow. Then we implement the changes, then the same changes that we apply will generate the new problems and issues, and that can be targeted within the same project of construction management. So that kind of thing we can have action, problem, and unintended consequences. Those unintended consequences can be controlled by using system dynamics approach. We define a problem. That's a system dynamic diagram of the same kind of thing. Define a problem, ask the questions, which the defining of problem will have more number of questions. So the positive signs are the direct additive to it, and the negative signs are subtraction to the thing. So forward and backward loops are being generated by these kind of things. We develop a mental model. Those mental models are mapped, and the best part of system dynamics is that we can model small mental models, and then we can club together all of them. Let's say we can map the labor component first, we can map the let's say material component first, we can map the financial component first. So all those things can be connected towards the end of it. So in the similar manner where we are developing the work breakdown structure or organizational breakdown structure, so these kind of responsibilities can be associated with this. System dynamics is basically approach and policy based tool where the policies can be generated, and the policy it helps in decision making to the manager. So it's an input based thing where process construction is a input based thing where the process, different type of processes are involved to produce an output, and the managers are trying to control it with the help of their tools that they are having. So the input, process, output, they produce the feedback also. So that feedback is available to the manager within this short span of time, which acts as an input in addition to the regular inputs that we are having in terms of resources. So that's the system dynamics advantage over the other linear thing. So these are different network project based methods where Gantt chart and line of balance, vertical production method, linear scheduling method, repetitive project modeling. So these kind of concurrent engineering, linear scheduling method, these were developed over a period of time starting from 1885. Then we are having some simulation based techniques also. Cyclic operations, Cyclone was the project by Halpin in 1977, the Forester project in 1965. That was not directly implemented on like construction project, but that was implemented on that project was urban one model was there. In 1979 model of unsaturated amine mud was developed by Carr. So similar kind of models were developed over a period of time, but the system dynamics process, which was started way back in 1965 by Forester, J.W. Forester, that is being utilized in different methods, and they are using the basic approaches that we are following, the CPM and PERT methods. They use those methods also, but these methods, the new tools that we are having, they help in developing the policies which can be directly utilized by the planner. So in the project which I was involved in, yes, I was Dr. Amit, I was thinking of coming to the base first. So after completing the base, I'll be detailing out those projects. So I was thinking that the construction thing, the construction technique thing, that I should focus in more time rather than. So that was a preamble only. I hope it was clear. So that was there. I didn't want to like enter more time into system thing rather than the actual product that I was involved in. So there the focus was in the project. Like whenever we are involved in any sort of construction management project, so duration of activity becomes the important, and the duration of activity is dependent on large number of factors, which may be the urgency of completion, which may be the climatic factors, which may be number of teams allocated to a particular activity, other activities dependence, whether a particular activity can be like is succeeded by some other activity or preceded by some other activity, space available for work and material storage, the construction process constraint, rate of raw material supply, work scope, technology adopted, and at the same time whether the money is being poured for completion of that activity. Or see, with these sportive things or the causes that we are trying to identify, there are other things also which are directly or indirectly implement affecting these duration of activity. If the client is not supplying the money, the number of teams allocated will not be available. So the rate of material supply may not be available. The work scope may increase or decrease with the available of these teams or the financial thing that we are having, or the regular decision making which was being done at the client end, or the, let's say, what we call project managers and or the decision makers and we can say, or at the lower end where the labor is unable to get a clear idea of what is to be done. So if the skilled labor is not available for a particular thing, like I was involved in one of the project in hotel park in Bangalore. So there it, not Bangalore, yeah, the park in Bangalore. So there it was more of like the scope of work was available, number of teams were available, space was not available. Similarly things happened when I was involved with DMRC. So in one of the stations it was like the space is not available below, the traffic has to be regularly function below the station. So those space constraints, those all the constraints allow or allow us to fix the duration of an activity to be performed. So we could only work during nights. So that kind of thing, that kind of constraint didn't allow us. So understanding of all the things in detail manner is required for becoming a project manager. So that's how we try to plan. Although with the experience, the number of duration of activity people filled with the say that with all the constraints, that is the duration of activity. That's how we function in a, let's say, Primavera or project MS project thing. So and we keep on allocating number of teams. So at system dynamics also we try to identify the activity, we try to identify their productivity, and we with the help of this productivity and team per day, we calculate. So we try to fix that how much amount of work we can do, and then we go with that how many number of teams can be allowed in a particular workspace. So these kind of things we also calculate, and we also calculated in our system dynamics approach. What we modulated like material cost, labor cost, higher charges, establishment charge changes that we require to find the activity cost also. Though, so the all the three things, the work breakdown structure, the organizational breakdown structure, the financial breakdown, also all the things were calculated, and with the help of these, the allocation of number of resources and activity duration chart was plotted. So for different activities that we require, so we tested. So this same activity, it was like activity work scope was hired, rate of work completion was being decided, that and it was decided based on the technology that we are adopting, the same JCB that we are using or the earth mover that we were having. So those technological changes were also available, and whatever was available with, like I was from the client side. So this, what they call, JLL was hired by the client Nokia Siemens, and the L&T was doing the project of Nokia Siemens building in Manyata complex in Bangalore. So there it was like the technology was available, and but the upgraded technology was not available at that point of time with L&T, and so they were focused only on the construction part, and the interior project was given to somebody else. So the construction process constraints were also part of it. So other activity dependence, maximum reliable. So this is the same thing, the previous thing that you were looking at. So this duration of activity was being decided in the same thing. So it's the system dynamics approach of the same activity duration. So these things are impacting maximum number of teams deployable. This is positive or negative impact that we try to identify the causal loop diagram of the same activity, which we try to identify in the linear process system that we follow in journal. So the same activity in system dynamics view, where the rate of completion, activity work, the technology adopted, the team size, team wage, number of teams available, rate of labor, funds available. So this is how the financial modeling comes into play, and this can be modeled with the help of like different tools. By using all the CPN per diagram that we are having, we can model these things here. Whether it is like the material or labor cost ratio, raw rate of material funds available, available material prices, maximum rate of material supply available, rate of funds available, estimated cost of unit work. So all these estimated things in what is actually available in the market at the time when we are implementing the project. So those changes in the gap, that the perceived gap that we have not identified at the time of estimating the cost of work, so they also are being part of the system, or are also part of the construction process. So manager is being fed by n number of things as soon as he fed the data in his daily chart. So the daily rate of processing is being generated, rate of material funds is available. So all these things are being generated in the dynamic module to, and those are available to the manager. So actual number of teams allocated, urgency for completion, activity material. Let's say some a particular activity is has to be to be succeeded by some other activity. So the urgency of completion is being forced on a particular activity. So the amount of labor and the particular set of contractor, let's say some masons, team of mason, the construction team has to go there, and let's say HVAC guy has to perform, and that HVAC guy require the electrical or the fire person to complete the job first, because the last phase he cannot allow his ducts to pass through a different set of zones where this electrical guy had to perform, because a single leak will destroy his entire setup. So he wants the other teams to finish first, and then the HVAC guy has to look upon. So the urgency of for completion of a particular type of work, the maximum rate of material supply available, and all these things are being calculated first, and then we keep on feeding the data. So that data feeding is becomes the dynamic activity, and all these things can be taken as output also. So the same thing in entire, with actual productivity achieved and the actual number of teams allocated, urgency for completion, effective working hours per day. So the effect of climate, overtime, effect of undertime or undercrowding. So all these things are being calculated. If you look at the right hand side of your screen, so this actual productivity achieved and the perceived one. See, estimated unit work. So all these perceived work. So the activity duration is, or the rate of work completion is being impacted by this particular thing, where the actual team productivity achieved is being calculated or being recorded. So this feeds the system in the dynamic mode right on the very next day. So, or right at the time when this number of workers enters in a particular mode. So this thing is being allocated, and the rate of completion of time and the activity duration starts getting increased or decreased with the help of this system dynamics or the dynamic module. So which is not directly available with the help of MS projects or the Primavera softwares. And see, this activity duration calls for then to Primavera software. It was linked to Primavera, and then the Primavera decision making team helped us to project which like specific person to be contacted for completion of the activity duration within the specified period of time. So this was the module that was introduced in the middle of the Primavera software with the help of system dynamics. We plan the planning adjust number of teams to work on a construction activity. Total planned productivity per day was then finalized. Estimated total funds required for activity at planned productivity was fixed. Adjustment was required. Whether it is, if yes, then we need to formulate the new team. If no, then the optimal duration of the activity is required. And let's say for a see, when we remain involved in construction projects, so at that point of time the funds are fixed at first, that these many number of funds, this much amount is being utilized for, let's say, HVAC, or with the fluctuations of, let's say, 5 to 10%. So those 5% funds are being extra taken care of in case the contractor or the labor is unable to perform a particular activity, so the extra question is being planned. So those activities, all these activities are being adjusted within that 5%. So the contract is being then called upon for performing the duty if we require like additional set of things. So in such case, the funds are not being provided directly to him. Then the deal of the person to person starts playing in action. So those subjectivity cannot be removed with the help of system dynamics, but the subjectivity is reduced with the help of system dynamics. And the system dynamics approach that we are having, that we followed for this particular, we proposed for a n number of 3 projects we tested first, and then it was implemented. So after this testing, whether the funds was available or the optimum duration of activity can be achieved within the specified time. Let's say on a particular day some labor is not available, so on next day they will perform the extra duties or the extra number of hours they'll perform. So effect of undercrowding, overtime, effect of climate, all these things are being involved, and the total planned productivity and rate of completion, they are then checked. This rate of completion and total planned activity period, so they are then checked. These two things in concurrence are checked to check whether the, so for the project we started with the questionnaire survey and data collection. Range of time lag between successive activity was identified. These things are like common things which we all do in our construction management things. And rate of possible work per day, all these things are calculated, but the only thing that was there, that was not there, was the feedback thing. So this thing, whether the feedback is being generated in the number of teams allocated to an activity per day. So if you have been involved in the construction activities or construction projects, like we are having some regular labor, and then we hire on daily basis also. So based on that effect, we can identify those daily labor requirement as soon as we are entered in the previous day, enter the data related to the previous day's work. So those time lags can be reduced by using this particular technology, and that has been achieved with it. So these were the periodic function where total project, optimizing the total project cost, total construction duration, peak material quantity, peak labor quantity. So all those things were like kept into the objective functions. See, when we use the system dynamic technique, these equations at the time of, let's say, our BTech or MTech or PhD, we might have been able to develop all these high-ended technical equations or scientific equations that we use, but with the help of system dynamics, we don't require such kind of equations. We require basic modeling. These equations are just a fear factor that remain us haunting throughout the entire project. So these kind of things, the peak labor quantity and everything, these labor productivity, available activity rate, where labor productivity becomes the function of average team productivity, number of teams or activity, and available activity rate becomes then function of construction process constraints and other activity dependencies. All these abbreviations are given here. And it has constraints of total project cost also, total construction duration also, peak material quantity that can be stored because the different constraints of the space or let's say supply, peak labor quantity that also remains available. How many number of teams can work there for a particular in a particular day, and what technical specifications can allow them to work. So the objective of proposed optimization process was to optimize the scheduling of construction activities subjected to the constraint that the total construction cost and the total construction durations remain less than the targeted construction cost and target construction duration, while the rate of requirement for labor and material per day per week to realize the derived construction schedule remaining less than the peak rate of labor and material available. Because at the same time, when we will try to reduce this let's say construction duration, the amount of money to be poured can increase, and at the same time the quality of supply of those things can decrease. So all these things were taken care of, and that was also that what is the probabilistic time and what is the optimistic time. So that optimistic time was also fed into the system so that the total construction duration shouldn't fall below that particular thing, because that also increased the cost. If we have to increase the, let's say, optimize or minimize the let's say duration, so we'll need to provide the more money. So all those things can be, if whatever policy that we require into system and everything, that can be calculated based on this particular thing. If we try to identify, let's say, the project cost has to be optimized. So all the three things, rest of the three things can become secondary. So at the time of when we are making the multiple decision making things, multiple criteria decision making, all the four things can be quantified in optimization mode, and that graph will also be available, that how much amount of resources we should utilize or we should put into for different type of activities. So all these things can be minimized or maximized based on the functions that we try to provide with. The results, the construction duration, the entire this process, the proposed mechanism was adopted for three different construction projects, and what one was at that point of time was a triple M Madan Mohan Malviya Hall of Residence for the boys. So that project was also taken care of. So the construction duration in terms of number of days and the total construction cost was plotted in into together. So in relation to the construction cost and construction duration, it was a linear curve, and the similar kind of curve was being seen or being observed for all the three projects. So this is the similar kind of thing that we observe in our regular projects and regular processes also. Same as they keep the peak monthly expenditure and construction duration. So cost in terms of month wise also being calculated. So with the help of with the increase in number of days, the cost, the peak monthly expenditure was getting reduced, although the total construction cost with the help of increase in number with the number of days was increasing. So construction duration, number of like rate of return started decreasing with the increase in number of duration of the construction duration or number of days. So this process was followed or was observed, which was regularly observed in our regular processes also, which are being, we are saying as network based problems. So all these techniques also provided or yielded the similar kind of results. So the model was running perfectly fine. So the conclusion was drafted. It was to develop the simulation based construction activity model that could successfully incorporate the relevant construction related data, which could emulate the progress of construction work as in the real situation. So all these things were actually tested in real projects. So at the time when Dr. Uma was doing his PhD, so at that point of time, the Triple M hostel was under construction, and in spite of the largeness of the data process required, see, these techniques can be utilized only where the multiple things are being procured or being constructed over a period of time. So it is not that the single house is being constructed and we can go with the system dynamic technique, or we can, but the uh, type of input that are required will hamper the construction duration or construction cost in part. So the proposed optimization method could successfully drive the optimal construction schedule in response to the objective functions and the construction constraints specified by the decision making. So the number of decision, the constraints can increase also, can decrease also. As soon as you try to see with the help of this tool, the tool that Dr. Uma developed at that point of time, it was like the tool, the scenarios can be developed with the changes in a particular rather than like the things that we have mentioned here. So those decision maker or the constraints can be changed also. As soon as you try to implement a constraint on a particular activity, let's say productivity curves you want to change, so the product with the help of productivity scenarios that you want to develop, it can be changed. So the proposed method was effective enough to develop the in adjusting the resources allocation to activities in response to the fluctuating market prices and productivity curve associated with various constraint activity. So the time lag between successive construction activities and commencing construction work in successive apartment blocks, which were triple M hostels, could be advantageously optimized while responding to the fluctuating prices of various construction materials. So the teams that were hired, the amount of work they can do parallel work in other sites also, but as and when required, they'll need to come to the particular triple M hostel. So that was ensured. It was a live site that we were involved in. So the proposed method could give the right platform for driving optimal construction duration and for large housing project where the repetitiveness is being defined. Further, it could define resources requirement to achieve planned rates or resource progress rates. It was planned for housing projects, although it was tested for other projects also, but it provided its robustness for housing projects. So, demonstrating the robustness of proposed method in adopting the various scale and configuration of housing construction project was established and effectively scheduled with this tool. So, the proposed method could aggregate the resource requirement into daily, weekly basis and could successfully optimize these daily peaks or weekly peaks and monthly peaks requirement for various project resources. And Powers in 2005 was used at that point of time. Nowadays, Vensim is available, and one more software, Stella, is also available for utilizing this. And nowadays, the tools that Stella is having, because I did my master's in urban physics, where I used Stella and Vensim together. So right from the time where I was involved in this project, I prefer to continue with system dynamic thing, and the type of questions that used to come to my mind that were like cause and loop kind of thing, cause and impact kind of thing. So those kind of statements and let's say 360-degree approach was being adopted in all the processes that I remained involved with. So both for developing the simulation-based construction activity model and carrying out the optimization process through these simulation models as was proposed in the method. So the method proposed in the study was proven successful and decision support system in driving the optimal construction schedule for large housing projects. And the another project that was being observed at that point of time was one housing was under construction at that point of time for teachers housing was there, so that was also part of the project. It was proposed to be adopted by the construction industry. L&T and JLL both tried to, they both were involved in IIT Kharagpur, that housing project and the hostel project. So that they were ready to procure that. So those, it was provided in first go to both these companies, and that was like first the model building process was adopted. So that model building process was being followed, and then the identification of optimal worksheet segmentation, which was done by their engineers, let's say L&T or JLL, both from the construction point of view and from the client point of view. Identification of logical sequencing was proposed. Then step 4 was to determine the maximum number of construction teams that were possible to work on each construction activity based on the space available and the technical specifications that a particular work can be completed within for safe working conditions and process constraint associated with that activity. With the involvement of Jones Lang LaSalle, it was like safety of those workers was also of very high end, and same was the case with the L&T. So by the same efficiency that regular project manager are calculating was found to be decreased over a period of time with the help of those usage of those essentials that they used to carry, be it like let's say the construction shoes, or be it the helmets or the construction clothes that they used to wear. So after setting the objective of the optimization process, optimizing the tool is the final step in driving the optimal construction schedule for the construction project, and that can be run with the help of like developing various scenarios. It had the feature capabilities which were also developed over a period of time by Dr. Uma, and I was also involved with him and as well as my supervisor at that point of time. So the capabilities of simulation-based optimization process method was proposed can be enhanced by incorporating overtime policies, which was not part of it. So the same overtime policies can help in decreasing the construction duration, even if rather than the hiring the more number of people. So the men working time can be increased by overtime policies and corresponding productivity and cost variation related to various construction activity. That was not done at that point of time. Considering the credit period available for various construction materials, so that can also be there, and it can help in developing, it can help in achieving various green rating systems, also incorporating volume discounts that are available and associated price dynamics corresponding to the procurement of various construction materials that can be supplied over a period of time can also be incorporated. So extending the model into which include electrical, plumbing, and other building related services. The first model was related with the construction activity only. So which was like say brickwork and concreting the entire site. So those two were tried and tested, so other things can also be used. Introducing weather related information and its impact on productivity of various construction activities can also be incorporated, although it was kept in mind so that the number of teams available was influenced by it, but not incorporated in the model, so that can also be tested. Thank you, Dr. Amit. It is back to you. It was really fine. Dr. Amit, just to add to this, I used the same tool in my PhD work also. So that PhD work was basically related to urban physics. So the same tool can be utilized for different type of things. If like the participants are willing to explore the tool, I'll be available. And the one system dynamic society is there, which remain available for free of cost, and they you can post a question, they'll always reply back to it. And most of, like, let's say the Sloan School of Management at MIT or Harvard, so these people, IIT Kharagpur was the first one to bring the system dynamics in Indian industry mode. And so their professor B Mohanty is there, and all these people are available free of cost, and they remain available for sharing their data. And also, when this data is being shared, they see, they present this COVID problem, they have modeled it, and it is producing a good result. So that can be good then.
So how this approach accommodate unforeseen delays in funds, material, and labor?
These unforeseen delays in material, see, as soon as the previous day data will be filled, it is, one is the projected date, proposed date, proposed schedule. Another is as soon as you will be producing the date. So those unforeseen delays, see, it is not the direct thing. It is the policy measure tool which which help the project manager to decide on a particular activity. So as soon as those unforeseen thing will hit that particular activity, let's say this COVID is being proposed, so that help the the lockdown period, that will help the project manager to make a decision based on the set of that these are the things that are being delayed because of this particular activity. So you should take a prompt action. So that policy tool will be there.
Please list other services along with plumbing.
Yeah, see, within a period of time, with the help of the Dr. Uma has to complete his doctorate also. So all these services couldn't have been incorporated at that point of time, and I was just associated with him because of the common supervisors that we were having. So the inclusion of all the services was not possible, and we in future will be able to do it, because I mean, now I have joined my institute back, the parent institute back. So I'll be working regularly on using the system dynamics tool. So I'm open with these applications part also. So plumbing, no doubt, I'll be taking care of, because of the services component that I've learned from my Kharagpur experience.
Sir, excuse me. Nowadays, apart from the main construction work, the services cost is being very high. Can you please list the modern or advanced services which we can use in the buildings?
Sir, in the present state that we are having, see, the tool don't help us to identify the techniques that we are already available in the market, that those are available in the market. It helps in to the first process is the survey process, where we'll identify most of the techniques or the tools in different services, which can be plumbing, which can be, let's say this HVAC or electrical work. So all these things
Electrical work, air conditioning.
in the first phase of survey, not the identification of the tool. The I'm not able to read this thing because the comment gets over as soon as I'm.
Techniques will help.
Pardon, Monica, I'm unable to read the things.
सर इट्स इन चैट बॉक्स राइट साइड पे देखो टॉप पे आप पीपल के साथ सेंटर वाला ऑप्शन होगा राइट साइड पे पीपल
Okay.
लिखे साथ चैट बॉक्स है यू कैन
Okay,
ओपन
okay. Somebody, Ruhil Khan, has asked regarding the CPN per technique and whether they'll be useful in the present scenario of COVID or not. Of course, yes. Why not? See, all these delays will be directly incorporated in different CPM or per techniques that ever the delays portion that we use. So those delays are being taken care of by the system dynamics approach also. So it is acceptable that these kind of things will be incorporated. No, we cannot do the event-based methods. It is not possible. Exceeding the project's budget. See, as soon as these exceeding the project budget and these things are being overrun by the project. So, if you might have noticed during one of the things when the activity was being planned there. So that activity the duration of activity has to be fixed on the particular, let's say, cost also, so that if that project is falling behind in terms of cost or lagging in terms of scheduling, so at that point of time these activities can suggest a policy measure only, that you should try to go with a particular thing. Let's say if we are involved with the banking sector, so if the project is connected to that banking component, so that will help us in identifying that you will require more amount of money. So that more amount of money has to be taken care of by the project manager and to be taken to the client. So this action is to be required by the client. So this is how we are working in our Primera also, where the work breakdown structure leading to all the money supplying part is not being provided to the client end, and it directly pop up a question related to it, that the money is required. So it is a policy based question, policy based thing, Dr. Amit, rather than the implementation based thing. It's a suggestive thing. Thank you, Dr.
Hello, good afternoon, everybody. And thank you very much, Raksha, for sharing your, Dr. Manoj Pawar, for sharing your thoughts and your say expertise with the participants. And I hope that this session was a little bit different, because earlier we have been focusing on some construction techniques and all that. So, but at the same time, because you cannot manage your projects without proper the construction management practices. So these two things are basically go side by side. and we cannot ignore them. So I think that this was also the very good input for our participants. And with your experience and with your expertise, they must have gained a lot. So thank you very much, sir, for sparing your valuable time. And we hope that in future also we will have lot of interactions.
Thank you, Dr. Shivan.
Is Dr. Ashok? You can interact now. You were missing interaction.
Good evening, madam.
Yes,
Good evening, Amit sir and all.